Hi everybody, and I hope you guys are doing great. I have finally finished recording all the videos of my latest tutorial that is going to be in the Nonlinear FEA course. And this tutorial is about the rear suspension assembly FEA modeling, this model that you see here. This suspension is part of this CrossKart vehicle that you see here. So my idea is that in this first tutorial, I taught how to assemble the rear suspension, which is what you see here. And then in the next tutorial that I'm going to start shortly, I'm going to teach how to create the front suspension assembly. And then in the third tutorial, I'm going to teach how to create the full vehicle model. So I'm going to use the rear suspension and the front suspension models, and then I'm going to put it all together and model the remaining components. So for example, I'm going to also include the modeling of the tires. And for these, I'm going to use a scientific article to extract a modeling strategy that is actually validated. And I actually do this for many modeling techniques. For example, for the seam welds, such as these, I have used a scientific article that validates this modeling strategy. Okay, so guys, what you see here in this animation is just a test that I have performed to check if this mechanism is working. And you can see that it's working pretty well, right? In this test, I have applied, well, in the first steps, I have applied bolt pretension. We have many bolted connections. Everywhere we have bolts. You can see both sides of these because I have applied a symmetry visualization tool here in this post-processor software. And speaking of softwares, the softwares used for pre-processing is ANSA from Abaqus, which is a widely used software in the automotive industry. And for post-processing, I have used MetaPost. And for solving, I have used Abaqus. Okay. So in the first steps, I have applied bolt pretension. So let me show this. So this is for the first steps. I have a bolt pretension. You see, we have this very small initial gap, bolt pretension to close the gap. And then after that, I applied an upward displacement on the knuckle. And that's what we have. And then after that, I have applied a downward displacement. This is just to check if this whole mechanism is working, and it is working. But you see that we don't have the spring visually represented here because I have represented the behavior of the spring on this system by using an axial connector. So we don't have it visually represented here. If I go back to ANSA, you see that we have many kinds of connectors here in the module, and then the spring is right here. The spring is right here. We have so many kinds of connectors here. We have a cylindrical connector, we have a Cartesian cardon connector here, we have a translator connector for the bolt pretension, and etc. This is a very advanced model. We have all kinds of things here. We have rigid bodies for these components in the spring and shock absorber assembly. We have shell elements, solid elements for these components here, for example. Anyways, and in this analysis, we have a total of 4 steps, actually 5 steps. Anyways, this is an advanced model. Just for you to have an idea, guys, look at how many contacts we have defined in this model. 56 contacts. Let me activate where we have these. So you see we have all these contacts. It's not, well, we have 11 tie contacts as well. And this is just for the rear suspension. Imagine when we have the full vehicle model, how many contacts we're going to have. Let me see here. Yeah, okay. So as I mentioned, this tutorial is part of my non-linear FEA course, and that's because we have all kinds of nonlinearities occurring here. We have large displacements, obviously. We have large deformations because, you know, there is plasticity occurring at some regions in the bolted connections. We have a little plasticity occurring, which is acceptable in regions of contact because they are compressive in nature. We have also frictional contact, which is another kind of nonlinearity. So anyways, we have all kinds of nonlinearities occurring here. So this is a pretty good exercise to practice about nonlinearities. And one last comment about this. Because I have added this valuable tutorial in this course, I'm going to obviously increase the value of this course because, you know, now this course is more valuable. But I'm not going to do this right now. I'm going to keep the current price for the next days. I'm going to describe in this in the description of this post how many days I'm going to keep the current price. And then after that, I'm going to increase considerably the price of this course to take into account this new tutorial. But right now, you can buy this course at the current price. Okay, well, that's all I had to show in this video. I hope you liked it. And well, let's keep learning FEA.